it's a substitution, but it's definite integrals instead of indefinite, which means we have limits of integration now. So it's very much the same process, except now we have to consider what those limits are. And there's really two ways of going about this, more than two, but there's two big ways, and we're going to do one of the two ways just to keep it simple. There's one way, the way that this book presents it is you go from this format here, this f of g of x times g prime of x dx, which is what we were dealing with earlier. And you change to an f of u du, and you never change it back because you also change your limits of integration. So I think this is the cleanest way to do it, is to change the limits of integration every time. I've done it before to where I would go back and then use the original limits. So I go back to the original function and go to the original limits. But this is another way to do these problems. This is the primary way to do these problems. Oh, do you want me to leave it up there for a second? Okay. So here's an example. What would you identify as the u in this case? What's our inside function? 1 plus 2x to the third power. Thank you. So our du would be 6x squared. We don't have a 6x squared. We have an x squared dx, 6x squared dx. So we're missing the 6, so we'll divide by the 6. We'll have 1/6 du equals x squared dx. Now, one other part to this is to look at the limits of integration evaluated through u. And what do I mean by that? I mean, we take u and evaluate it at 1. We take u and we evaluate it at 0. And these are just these limits of integration. There's no magic going on here, no Harry Potter time. So u of 1 is what? Well, we said u was 1 plus 2x cubed. So it's going to be 1 plus 2 times 1 cubed, which is 3. And u of 0 is 1 plus 2 times 0 cubed, which is 1. So why did I do that? Because now I can change this whole integral to become something equivalent. 1/6 times the integral of u to the 5th du, and my limits now are 1 to 3. They changed from 0 to 1. The 0 became a 1. The 1 became a 3. So what is our antiderivative of u to the 5th power? Very good. So it's going to be u to the 6th over 6, and we evaluate that from 1 to 3. No plus c's because it's a definite integral. So we have 1 over 36. I hope you see that from the 6 times 6. We have 3 to the 6th minus 3 to the 1. And 3 to the 6th, that's one I don't have memorized. That's 729. I should have it memorized. 729 minus 1. No, minus 3. No, what is it? It's 1. It's 1 to the 6th. Man, that's the second time I made that mistake today. So we have 728 over 36, and that reduces to become, we divide by 4. I get 182 over 9. That's it. So it's a little bit different work. You don't have to go back and plug things in. You put in the limits of integration. So let's try one more in the time we have left. Okay, what would you choose your u to be in this case? 2y squared minus 3, good. So our du would be 4y dy. So it would be 1/4 du equals y dy, because there's no 1/4 there, or no 4 there. Okay. So the second thing we have to do is look at u evaluated at 0 and u evaluated at -1. What is 2 times 0 squared minus 3? And what is 2 times -1 squared minus 3? It's going to be 1, 2 times, yeah, you're right, -1, good. So this becomes the integral. Really? Still -1? It goes from -1 to -3 of our u, or I forgot the 1/4 of u to the 5th power. What's the antiderivative of u to the 5th? So I get 1 over 24 times -3 to the 6th power minus -1 to the 6th power. Oh, that's funny. -3 to the 6th power is also 729. -1 to the 6th power, it's a minus and negative, so it makes it just a minus there. The negative gets square cube 6th root down, or 6th power out. And then we end up with 728 over 24, which that does reduce to be 91 over 3. Okay. I got 3 minutes. Let's just do one more. One more. This will be a fun one. Well, they've all been fun. This will be more fun. It's not sure I can do it in 3 minutes. Okay, this next one, check this out. We haven't done an E1 in a while. So this part, that's a power for your E, that's what I call the U. So EU is what? 4x squared plus 3. And then what's your DU? What's the derivative of 4x squared plus 3? 8x dx. Good. So we need 1/8 du gives us x dx. So we line up there. So we're looking at the integral. I've got a 1/8 of e to the u du. I got to do my limits now. What is u of 1? What is u of 0? 4 times 1 squared plus 3. I get 7. 4 times 0 squared plus 3, I get 3. Okay, what's our antiderivative of e to the u? Very good. E to the u evaluated from 3 to 7. So we're going to end up with e to the 7 minus e to the 3 all over 8. And that approximates to be 134.568. That's it. We'll stop there. Won't go any further. Okay, fun stuff. I would encourage you to start that section. Oh, no, I put my tab on my thing. I would start it and see where you get with it. We will finish that next time. We'll do the exponentials as well. So hopefully next week or Wednesday, we could do the best joke ever. Waiting all semester for this. Okay, bye everyone. Thank you.
Just a question.
Yes,
After we know in module 5, what are we going to be doing next week?
we got a couple of things from module 6 I want to cover if we can get there, and then we'll go on to we'll do the module 5 exam, and then we'll do